Grape, strawberry, or
My
blueberry?
shoe, man. What?
Grape, strawberry, or blueberry?
I think I got an eyelash in my eye.
Blueberry? Okay, I got things to say. We gotta get going. Okay.
Is this stuff new?
Not really.
So
Not
is
yet.
this like contours yet?
You already on it.
Came from blueberry.
Okay. Great. Let's go ahead and talk about all the things that I need from you. What did we do yesterday?
We got caught up yesterday on our tests,
And?
our books, and anything that we were missing.
And she can get a point. You were supposed to start something. What page were you supposed to start something new on? What page is it?
3.1.
Number 1 through 5. Do you know what page in your book that is? Find it. So who's first?
25.
It's 25. 2 out of point. Okay, so you were supposed to have done page 25. If you're looking at page 25 currently and it is blank, you are already a little behind today. You got to get it together, which is no big deal. You got this, but you got to get it together. We are super behind on something else as seen by the dates on the screen. What are we behind on? We are so behind on workshops. So what we're going to do is we're going to do 1 through 4 today. We haven't done 5 through 10. We're going to save those to Thursday. If you're good at factoring and you're trying to get your group points, it would be wise to go ahead and have these factoring ones done by Thursday so you could just rack up on all the points. Okay, let's start at number 1. And so we're behind, which is my fault, but we are going to get caught back up eventually. Huh? Where are these? In the 2. Yeah, if you didn't have them, they were in the 2 of the crate. We've had them for forever. We just got behind. Well, we kept trying to get caught back up on truth tables, and it's like we got so caught up on other stuff, we forgot to get caught up on workshops. Okay, so factoring is not everyone's favorite thing, but it is nice when it has a 1 in front of the leading coefficient. 1, 2, and 3, do they have a 1 in front of the leading coefficient? The second. Look in the 2. Andrew, were there any more? Okay.
No, it's 2 tables.
Andrew, help her find them. Okay, never mind, Andrew. She got it. Okay. On 1, 2, and 3, do we have a leading coefficient of 1?
No.
Yes.
1.
Yes, the leading coefficient, meaning the number from the square root is 1. So 1, 2, and 3 is going to be easy factoring. Okay, easy factoring means I need 2 things that add to give me the middle term and 2 things that multiply to give me the last term. So for our first one, I'm wanting 2 numbers that add to give me a -4 and 2 numbers that multiply to give me a -32. So what 2 numbers am I looking for? Brittany, get a point. -8 and +4. -8 plus 4 is -4. -8 times 4 is -32. That's perfect. So since we're saying it's -8, one factor is m minus 8. Since we said +4, the other factor is m plus 4. Now, I swear there's more we can do with it once we factor it. But for now, we're just reviewing can you factor it. We'll get to what you can do with it once I know for sure, yes, you can factor it. Okay, number 2 is going to have the same logic. I'm needing 2 things to add to give me a -5 and multiply to give me a -66. Go ahead and tell me table 1. -11 plus 6 is -5. -11 times 6 is -66. So my factors are z minus 11 and z plus 6. Perfect. Are there any questions on number 2? And then we get to number 3. I need 2 things that add to give me 13 and 2 things that multiply to give me 40. 8 plus 5 will work. And 8 times 5 is 40. So my answer is y plus 8 and y plus 5. So we're rolling when the leading coefficient is 1. Life seems pretty good. Is the leading coefficient 1 on number 4? How many terms are there in number 4? So we're not going to be able to factor this the way we've been factoring 1, 2, and 3 anyway. What's the first thing you should do on any problem?
Take out the greatest common
Factor and Brittany get another point. So is there a GCF we can pull out? What can we pull out? There's something higher than 6. Yes, Andrew? Okay, if we factor out a 12xy you're left with a 3x minus 4y. And literally that's all we can do. That's as good as we can get. Okay, why are we doing this? This has nothing to do with what we're talking about in class right now. But you're either getting ready to take the ACT one more time, or maybe the college or wherever you're going has some sort of test you're going to have to take to place you into a class. And so we can't let go of those Algebra 2, Pre-Cal, etc. skills just because you decided to take Discrete. Cannot let it go. Okay, it's super old. Super duper old, Misha. You have it. It's that old. It's from 10-2. Okay, so again, not tomorrow, but Thursday, we're going to do 5 through 10. We're going to do that many of them. We're not doing them tomorrow because, why?
We have a test tomorrow.
We do not have a test tomorrow. I told you already.
You're not going to be here.
I'm not going to be here tomorrow. So, I want to be able to get points for the factoring stuff. So, we're just going to assume you're going to act awesome and get points. Last time, y'all were so good, she wrote like, this was like her favorite class. If she writes something like that again, then I will definitely add a point to every group. If she writes something awful like, Grant never did nothing, then obviously I'm going to take a point away from Grant's group. But if she writes a note like, Grant was so helpful and kind, or something like that, then I will add extra points to Grant's group. And I've apparently lost my mind, because I'm going to tell you more words in a second. Did you? You didn't know to. Did you pick up the cute little slip on the way in? Yeah. Okay. Now you know. Anything line up there you want. Jim, will you hand this Mallory?
Yeah.
Perfect. Yeah, it's yours. It's yours forever. Okay, let's talk about what you're going to do tomorrow without me. So, you're going to actually do 2 different things. Today we're doing a cute little short note thing on sample screen. Tomorrow there's going to be a video of me going over a cute little short thing on my favorite thing to do when I get to a problem, which is draw a truth table. Not a truth table. I don't know what a truth table is. A tree diagram. Tree diagram. So we've talked about tree diagrams in the past, and you ignored me, but you're going to hear me out now. A tree diagram is the way to go. Okay, open your book to, I guess, page 26. Okay, so today, Irvin is supposed to do 1 through 8. Our goal is number 8 on this activity involving ice cream. So I'm going to put star by number 8. That would be smart. When you put your star by number 8, I would probably add these words. Tree diagram. On number 8, you want to draw a tree diagram. It will make your life easier if you draw a tree diagram. If you're trying to, like Lauren is, trying to do all the things and think about all the different scenarios in your head, it gets confusing. It's better to draw it out in a picture or a tree diagram. Okay. Now, just because our goal is number 8, if you were already past that and you want to keep on going, that's fine. We're going to, tomorrow it will say you need to have finished 3.1.1. So if you're worried you're not going to be as productive since I'm not here to answer your questions, maybe it would be smarter to get past number 8 today. Okay, there is a secret I have refrained from telling you until now. And I will tell you it. See these 2 books that are super thick? They're answer keys. Woo! Now, I've let people look at my answer keys before. Haven't I, Brittany?
Yes.
Haven't I, Lauren?
Yes.
Now, they put a lot of words on the answer key. They put so, first of all, I'm a no, because you don't use that many words. Heck, I don't use that many words. They put a lot of words. But I'm going to leave a note to the side that says, if your group gets stuck, and they try, and they just don't understand number 7, you're going to be allowed to look at my answer keys from here on out. Just so you know. Even today, if you get stuck on one and just want to compare, that's fine. You need to have done some math on your own and thought it through. But you can consult my answer key when you get stuck. I have 2 of them. That is the good news that I have refrained from telling you until now. Oh well. Let's talk about how we're going to bridge the gap. Okay. Last chapter, we talked about what? What was our last test on?
Truth tables.
Truth tables.
Yep.
Terribly annoying. Wish they would go away. Too bad I'm going to tie them to this today. And you can have a point for that. We've been talking about truth tables. what is good about a truth table? What does it list out? All the possibilities. So that's what we liked about it, and that's what I like about a tree diagram. So whatever you need to do to have a list of possibilities. Except we're going to call it the outcomes. So that first blank is outcomes. Because let's be honest, possible possibilities kind of sounds redundant. So we're going to say all the possible outcomes. So when we're doing an activity, like today with there's ice cream and cones, there's a limited number of how many cones, how many different types of ice cream, and that number that we're choosing from is called a sample space. So all the possible outcomes are part of the sample space. In fact, let's go to definition. Sample space is the collection of all possible outcomes of an experiment. So if we're going to have a list of all the different outcomes of an experiment, that is our sample space. Okay, so I don't know if you looked through chapter 3. There are no truth tables. We're simply doing something called counting and counting techniques. But eventually this is going to get to probability, and we're going to get to things called permutations and combinations. So what I need is for Grant to get the easy stuff down, because I swear what happens is Grant will have the easy counting ones under control, and then once I blow his mind with permutations and combinations, he'll never be able to do an easy one again. Grant, you had a question.
I was about to ask, is this like permutation?
Yeah, no, we're not going that deep yet, but eventually I need, when you see a random question, to know this is an easy one, this is a permutation, this is a combination. Okay, so a sample space can be used to find the probability of an event occurring. Now, some probabilities you're just supposed to know. A coin has heads or tails, so the probability of flipping a tail is 1 in 2, so 50%. A deck has 52 cards, so the odds of you picking out the ace of spades is a 1 in 52. There are some things you're just supposed to know. But otherwise, to make a list or a tree diagram or something like we're about to do would probably help. We're going to make a table, in this example, to find the sample space for tossing 2 coins. So we could have 2 tails, we could have a tails and a heads and a tails, or 2 heads. Are you okay?
No.
What does this remind you of?
Truth table?
Yeah, that's the problem. Add a point. So when we list all the possible outcomes, it's suddenly like, oh God, here we are again with T's and F's. Because T and H is pretty much T's and F's with all the possible outcomes. So the first question asks, what is the probability of getting 2 tails? So what is the probability of getting 2 tails? 2. I see it. It's that 1, and there are 1, 2, 3, 4 options, so it's 1 out of 4. There are 1, 2, 3, 4 options. It's that one thing, so 1 out of 4. You can. You can. Now the next one says, which by the way would be 25%. If we were to turn things into percentages, because you know eventually with probabilities we will, so it's not a bad idea to get in that habit. What is the probability of getting a heads and a tails? It is 1/2 because it could do tails heads or heads tails. They weren't specific about the order it had to come in, so the heads could be in the first or the heads could be in the second. So it's the 2 middle option, so it's 2 out of 4, or 1/2, which is 50%. Now again, we could make life more complicated, and we could say, what is the probability of getting a heads and a tails with heads first? And then it'd be 1 out of 4 again. Okay, are there any questions about this? Flip to the back, and I believe it's upside down. Okay, so kind of like today's activity where there's going to be ice cream and cones and flavors and what if you want to mix the scoops and all this jazz. We could have something more complicated like a spinner. That's a little harder than flipping a coin. Does it look like each color is represented pretty equally? Yeah. So they each take up the same amount of space. What we're going to do is fill in a table to help us with our probabilities because they want to know like the probability of like getting 2 reds, getting 2 yellows, to getting 2 greens. So it's easier if we fill in a table first. So if I spin a red and red, that's going to be RR. If I spin red, then yellow, that's going to be RY. Red, then green is going to be RG. Red, blue would be RB. And then red, purple, RP. Does anyone not understand how we filled in that top line? Okay, well then let's fill in all the other things. Yellow, red, yellow, 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 green, yellow, blue, yellow, purple, green, red, green, yellow, green, 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 blue, green, purple. I'm telling you, you got this. You don't need me. You already understood what to do. Still got some writing. I'll give them another second. Now, it was a pain to write this out. I get that. But now that we have it written out, we can reference it and get all our probabilities. So drawing out a picture like this, or a table, or a tree diagram, or whatever, makes our life so much easier, rather than Lauren thinking in her head, like, what are the odds of getting a red red? How many options are there? Now she has a concrete table to look at, and she can actually circle and everything. So the first question says the probability of spinning two of the same color. Does someone know the answer?
Why not 26?
26.
So 1/5.
It is 1/5. You can have a point. Aren't there 25 total on the table? How are you at 26? So there are 5 this way, 5 this way, so there's 25 total on the table. And then we're wanting to know what about the doubles. So like red, red, yellow, yellow, green, green, blue, blue, purple, purple. There are 5 of those. And 5 over 25 reduces to 1/5.
Do you have to reduce it?
No. Really don't care. Because, you know, eventually we're going to change it to percentages and say 20% anyway. So I really just don't care. In fact, it might be more useful to leave it unreduced. That way you understand there were 25 options to begin with. Whereas when we reduce it, now it looks like there were only 5 options to begin with. I do see that argument. Okay, and the next one says, what is the probability of spinning a red and a green? Red and a blue. Red and a blue. Miss Compton, read. It is. You can have a point. RB or BR would count, and there are 2 of those, so 2 out of 25. Anyone know what percentage that would be?
It'd be 8%.
It'd be 8%. Table 1, get a point. If you type 2 over 25 in your calculator, it's going to be 0.008 or whatever, and you change it to a percentage, it's 8%. Okay, the last one is, what is the probability of spinning a green and a purple? I heard it from 1 and 3 and 5 and 2. Every group can have a point. 2 out of 25. Okay, again, it was a pain in the tail for us to list all this out, but once we did and we started counting probabilities, it actually made our life a lot easier. So you're going to tune me out and go to the book and think that these are 2 different worlds that we live in, but it would be smart if you would take what we've learned from this sample space note taker maker, or whatever you want to call this little piece of paper. It would be smart to take it and apply it to the junk you're trying to do in the textbook. Are there any questions about this? Okay, your goal is to get to number 8, but just because Irvin hits number 8 doesn't mean he has to stop. Your goal is to get to number 8. You're good? I'm going to stop recording. Get busy.